I said, what we're sort of going to explore today is a little bit more about how behavioral algorithms actually work. And what I'm going to do is take us through a couple of different areas in order to provide context on why we would want to even answer a question such as this. I'll be looking into things like, how do we define behavior and why is it important to know about behavior? And also touching a little bit on what the problem is with regards to human behavior at the moment, and particularly in relation to algorithms that currently exist. So I will then be unpacking a little bit more about the ways that we can use constructs or approaches like behavioral design in order to inform the creation of behavioral algorithms. That's about the point at which I'm going to hand everybody over to Eric for some practical walkthrough with regards to how it is actually created. But for now, I wanted us to sort of explore and really pin down and define what it is that human behavior actually is. Human behavior is defined as the way in which one acts or conducts oneself, function within social environments, or in this case, within digital environments, in terms of the ways that they interact, the ways that they learn from their environments, the ways that choices are made, and the determinant factors of those. And so we can look at a number of different facets, such as what is the context. Now, context can be considered in a couple of different ways. So the first is obviously the environment, like I mentioned now. Other very important aspects of it are timing. Timing means a lot for humans because it's fundamentally shape how a reaction comes forward depending on where that person is within either a daily life cycle or a monthly life cycle or even a yearly life cycle or a lifetime life cycle. And if you don't get timing right, it can have quite ulterior responses or reactions than what you would ultimately want. So some of the other things that could inform behavior, but also shape behavior in a lot of ways, are past experiences. So things that have determined how a human wants to interact in future environments based on what it is that they have already learned. Now, if we think about this in a real world setting, this would be a prime example of stove is hot, don't touch, or you're going to get burned. So you've got sort of an extreme version of past experiences, but then there's also past experiences such as if somebody has a particular name, then you could have a negative connotation associated with them, or a positive one at that, or the cadences in which people speak, or, you know, subtle factors that sort of shape how behaviors are shaped from that point forward. So there's also then incentives. So incentives are very much in relation to the digital environment. So what are the ways in which behavior is ultimately rewarded or potentially penalized? And how can these incentives be used to then shape behavior moving forward, or to somehow override past experience defined behaviors or potentially context defined behaviors? So how do you change that behavior? Another thing, which is a lot more of a variable, especially when it comes to the human in a human realm as well as within a digital realm, is this role that emotions have on how a person is going to act, or more importantly, react to how things. So emotion comes up in a lot of very interesting ways. Emotion is volatile and it is unpredictable, affected by these other areas of how behavior is shaped as well. Other times we'll have emotional actions that then inform decision making, which, if not sort of posed correctly enough, can ultimately lead to more sort of like unwanted responses to things. All right, so These four elements are very much within the digital sphere, and they can each be used to ultimately understand how we can create algorithms that can intervene or potentially analyze and make recommendations by looking at the whole human. There is a problem, though, obviously, with regards to all of this, especially when it comes to behavior within the digital landscape. So the digital environment creates a barrier between the human's humanness and oftentimes the systems in which these digital infrastructures were built, or the infrastructure in which these digital systems are built. And, you know, what you have then is also this very direct way to speak to humans that are on the other end of some sort of screen or some level of touch point. So you have high levels of competition, there is high levels of influence within these spaces, there is often a lot of competing ideas. So it's not even just competition in the space of, you know, your offer is better than somebody else's or somebody else's is better than yours. It is the nature of how information is processed or how information is delivered as well. Now, we know a very simple fact, right? Human beings are variable and they are very easily influenced by all of these different factors. So the problem ultimately comes in when we have to consider not just how much impact we have on behavior, but how can we intervene in order to ensure that the right behavior is funneled and encouraged. So humans, again, with that emotional facet, humans don't always know what the right thing is to do. I mean, I think very often humans don't know what the right thing is at all, because there is no real right thing, right? It is just competing thoughts and it's competing ideas. And so it's very important to consider how to use behavior in the right way in order to encourage or to influence or to recommend. Now, because a lot of the digital systems were designed to, you know, be systematic, like static, right? So you needed something that was going to be presented in such a way that it is, here is your offer. It doesn't necessarily matter who you are, but it matters just what sort of social environment you exist in. What happens is that you end up influencing in a way that is alternative to the human and that human's preferred behavior on the other side of that screen. So this is then fundamentally like why these algorithms fail and why they struggle ultimately. So it's the current environments are outdated. They're often relying on social influences, or they are relying way too much on A/B testing situations where it is the majority rules. And in this current landscape, in the current social landscape at least, the majority rules is not the right way or the most effective way to communicate with people. Now, it can often be referred to as using behavioral cues, but that also then sometimes has its problems in that some of these behavioral cues are often picked up from the systems themselves and not necessarily the individual. Now, this is where behavioral design could come in. So behavioral design it started as a design technique in the very real world, and it was often associated with policymaking or governmental tasks, at least in the earlier days, where people needed to resolve problems such as spatial design or potential ad placements or creating social calls to action or possibly even propaganda material. Like, behavioral design is very much about trying to understand how people function within very social environments. And what's happened over time is that it's narrowed down to the point where it can be used to craft environments that can play on known psychological triggers and design interventions that ultimately encourage change in human behaviors. So it's also used to address other elements, such as optimizing how decisions are made, or the ways in which interactions are posed, or the processes you go through with a potential customer or somebody on the other side of that digital environment. So behavioral design is not something that has been considered as often as it should have been within digital systems. So even in digital algorithms, which are often not very much about the human, but more about the system's behavior. And it is a flaw. It's not necessarily a flaw in the origins of the design of the technology, but more a failure to progress as quickly as it should have. So behavioral design or behavioral constructs should have been brought in far earlier than they have. And it should be something that is considered a lot more now than what it has before. And it doesn't always focus on like extracting human activity from the data, but also trying to figure out ways to identify and understand the human, or its ultimately personality. Now, personality is a very important part of all of this, because personality, from a human perspective, defines very much how a human interacts, why they interact the way that they do. It determines decision making, it encourages choices. It also speaks to things like energy consumption from humans' perspective. So how is it that this person likes to interact with their own energy and within social environments or digital environments? And there's a number of other important mechanisms that greatly impact the human's ability and propensity to act with some kind of a positive way to your recommendation. So this then leads us to, looking at how these algorithms can ultimately be made. So I'm going to hand over to Eric over here, who will talk us through designing behavioral algorithms.
Thanks, Jess. So yeah, we're going to talk about two categories of these behavioral algorithms. The first one are what we call personality-based and then decision-based. They complement each other. So the first thing we'll talk about is personality-based behavioral algorithms, and the idea there is to find patterns in a person's interaction data with an organization that tell us something about their behavior in relationship to that organization. So we're not trying to say, like, who is Jess as a person? We're trying to say, who is Jess and how does she behave when she's interacting with her bank or her telco provider or an app that she's using. That's the kind of personality behavioral thing. So it's kind of more of a generic insight development gaining process from your data. And then the decision algorithms are then to allow you to take action on that. So that gives you what Jess was talking about with the context being important and understanding that. And then the decision algorithms are ways to use that context and take into account the variability in people's behavior. So the learning from changes in their behavior over time and engaging accordingly. To start off with the personality behavioral algorithms. So the way that those are built is, at a high level, there's kind of two steps. So basically, you would develop a behavioral construct, a social science type of hypothesis that we think will be reflective of how people behave in a specific context. So, like I said, in relationship to their bank. And we decide what we believe that hypothesis will look like. And then we will look for behavioral indicators of that hypothesis in the interaction data. So if you are engaging in a certain way, we review that will indicate this kind of position in our behavioral construct. And that is obviously an iterative process, both in terms of the initial design and saying, like, we think we'll see these indicators and they're not there, or we see something else while we're looking, but also in terms of validating the hypothesis once we're engaging with people. So we believe we have this construct with these indicators, but when we engage with people, they don't behave the way that we would expect them to. So then we need to go back and revisit that construct. So there's a cycle that goes on, and that's obviously quite a multidisciplinary sort of process. Psychology, social science, computational social science, data science. You have to bring all of it together in order to complete those two. It's quite simple. It's only a two-step process, and you've got one. But it's quite a multidisciplinary effort to build these out, and that's all quite abstract. So I often like to if you just go down to the next one, like a concrete example of one of these constructs or personalities is the Spotify Wrapped personality, which they kind of tell, for those of you who use Spotify, kind of at the end of the year as part of their wrap up thing, they'll tell you what your Spotify personality is. And to talk about the two steps of what they've done there is their social construct is an adaptation of the Myers-Briggs construct, where you have your introvert, extrovert, thinking, feeling, intuitive, judging, the other one. And so there's kind of these 4 dimensions that you are across, and that gives you 16 different personality types. They've adjusted that to their space because, like I said, you don't want to try and say from Spotify, what is Eric's Myers-Briggs personality? You want to know what is Eric's personality in relation to Spotify. So they've developed their 4 dimensions, which are then exploration, familiarity, newness, timeless, variety, loyalty, and uniqueness, commonality. So they have this construct that they've developed, and then they have said, given our listening data, what indicators of Eric's position across these 4 dimensions can we find? And they then run that and put me somewhere on a spectrum across each of those 4 dimensions, and then done some algorithm to bucket me to say I'm more this way than this way, or I'm more this than average, whatever approach they want to use. And then they can put me in, say, the Voyager and give me that personality. It's interesting for me, but they can also use that to then inform their further engagements with me, both in terms of what they recommend and potentially how they talk to me. So I think I often find this a helpful example to make the whole thing a bit more concrete, because it's something that a lot of people have seen. So this is just an example of how that can happen in a different space. So this is a digital interaction personality. So what is your personality in how you're engaging with an organization through their digital interface? And here we've taken a slightly different construct where we have intentional, industrious, enthusiastic, and experiential as our 4 dimensions that we're looking at. We also have introvert and extrovert within and around that, but that's these 4 are kind of the part of it that's illustrated here. So in the same way that Spotify have exploration, timelessness, loyalty, commonality, we have these intentional, industrious, enthusiastic, experiential. We found these are often quite useful dimensions to look at in the space of you engaging with the company. And we then say, build out a set of indicators. So the ones shown here are, what is your habitual behavior, level of habitual behavior in that app? Are you always going in on Monday morning and doing the same thing? Or do you have you go in and do things as and when it occurs to you? How much do you plan things in advance? How do you communicate with us? So we have a list of those, and then based on where you fall on those, we map that onto the social construct, and that gives us an indication of where you fall across the different dimensions. And we can then, if we need to, bucket you into different groups to inform how we engage with you based on that. So that's another example. And then there's a kind of example of how you can take that social construct and find indicators in the data and map it onto it. I think the next slide is some other personalities that Jess will just talk to give you some more examples of what you can build using that process.
Yeah, so looking at the personality algorithms, we just listed 3 over here, and these are the 3 primary ones from us at Ecosystem AI. So Eric has just talked us through how you can understand or define the digital personality. It can be used to map quite well to app interactions. So what is the nature of how those people perform actions or not perform actions when they're stepping through an app? Is there any kind of habitual nature to the visitations to the app, but also to the actions that they perform in the app itself? There's also then spend personality, which speaks very much to its name, and it's got a lot to do with how people spend their money. And this would look at certain things like categories of spend or locations of spend, the rhythms with which they spend. So you'd have the same 4 or 6 personality types, but if we could just look at 2 examples from extreme sides, that would be our industrious or enthusiastic. So an industrious buyer tends to be your very common one, and they would spend in very habitual ways, but with subtle indications of variance within that. Whereas your enthusiastic spend with a lot of variation and subtle cues of ritualistic elements within that as well. Now, there's also the money personality, and the money personality is about the bigger picture. It's about seeing somebody's relationship to their money. It's more than just spend. It is also the ways in which people save, invest their money, the risk levels at which people interact with their finances. And yeah, it gives you a more holistic view of a customer. Now, just as a note with regards to these personality algorithms, is your spend personality and your digital personality can come from a place of not having that much information about people. So you can use derived data from personality profiles that are already well established in order to determine how newcomers into a space would have their personalities defined as well. Whereas the money personality has got a lot more of a timely nature to it. So you would tend to need a little bit more about a person and use that in a very effective way. And then, yeah, Eric can talk us to the decision algorithms from earlier.
So, like we said, the personality gives you insight and information about someone, but it doesn't actually, you need to do something with it for it to add some sort of value. I mean, that insight obviously has value on its own, but you need to act on that in some way. So the decision algorithms are a way of using that context to inform your actions, and also taking into account the variableness nature of human interactions and behavior and adjusting based on those. So it's basically a kind of real-time continuous learning algorithm that learns from each engagement within the context that you give it. And that context can include your personality metrics that you've derived for those people. So can include other data points as well, but we find that using those personality metrics is generally quite a useful piece of context to give it. So there are a number of different ways of doing this. A couple of examples of algorithms that we have implemented in the ecosystem platform: the epsilon-greedy algorithm, which is kind of the simplest version of this, where you set an epsilon value, which is kind of a percentage, and then that percent of the time you show people a random engagement, and you use that to learn and detect when things are changing, and the rest of the time you show them what you believe to be the best engagement for them based on what you've learned in your epsilon sample. And then naive Bayes is an approach that just allows you to incorporate more context. It's a kind of basic classification algorithm that uses an assumption in Bayes' theorem to train quite rapidly and predict based on the context that you give it. And ecosystem rewards is an adjustment and modification to Thompson sampling, which tracks your explore and exploit balance and tracks distributions for the different engagements and uses those distributions to decide where more exploration is necessary, where exploitation should happen. Q-learning is kind of, you define a reward policy and it fits more in the traditional reinforcement learning paradigm. And there's a bunch of others, but the idea is I think more what's important here than the details of how the algorithms work. And that is to say, use your behavioral context that you have from your personality to inform the dynamic learning that you're doing in your decision algorithm in order to engage with people in the most effective way. So yeah, that's our presentation on behavioral algorithms and the two types of them and how they work and how they work together. So I don't know if anyone has any questions, and thank you. That's Jess nudged me to say.
Yeah, thanks, guys. I don't know if there's anybody that had any questions on that.
I just think that just a couple of the algorithms that are also supported in a runtime that might be worthwhile talking about separately, because what's happening with the loss aversion versus risk aversion, if you think about it, the person that is scared of losing versus the person that's scared of taking a risk means that it shifts the model convergence quite significantly. And if you want to think about getting something like Q-learning to work properly, for generic product recommenders, loss aversion almost always works better than most algorithms. And actually, I find that in some of the recent tests that I've done, is loss aversion is probably one of the most successful dynamically converging models, even compared to the system rewards algorithm. It outperforms it in performance, especially in the face of having customer-specific evidence. So we set it up so that you got, let's say I'll take your last, 2,000 interactions, so anything that I've learned from you. The model gets trained in about 18 milliseconds. It can converge quickly, and it will really quickly shift its behavior because it knows that the person is going to adjust based on loss, if that is a scenario. If it's a risk-based, it converges slower, and you can use less evidence to convert it slower. So often for cases where you want quick shifts and change, you will probably use those algorithms and not the four that we discussed now. So there are different cases that might be applied in different settings. Anyway, maybe that's worth noting that there are a few others there.
Nicola?
I'm not sure if you can go into more depth about this, but in my mind, there's kind of a missing link too. There are all these personality constructs, and then there's the executive layer, which is like the epsilon-greedy algorithms and all of that. But how do the constructs translate into the algorithms? How does that get moved into the execution layer?
No, that's a great question, because all of them have one thing in common. And in fact, all probabilistic models have one thing in common. And that means that the ability to interpret evidence based on a contextual situation. So if you think of, let's take a handful of cases. Let's say that I want menu items on a screen to converge based on everybody that use my website. Let's take a very generic case. you normally will not set it up at a personal level. You might just set it up as a model that is slow converging. And that's where, you know, even if you think of epsilon-greedy or any one of those kind of generic algorithms, where it can work, but because it randomizes at a rate that you don't know, means that its explore capability could create a confusing situation where you log in and a menu item that you're supposed to look at now appears on the right because it's busy testing, it's exploring. So that means for that scenario, you might not want to set explore on at all, but you still want an algorithm that converges on what is being used. So you don't want to set those parameters quite distinctly. But if you have another case where you've got complex product offers and you've got product packaging and you've got, you know, for every single person, there are like 5 different options that I can select that is just for Nicola, then they definitely do not want to use that kind of approach at all. Then what I want to do is I want to be able to take, if the decision is, I know exactly what I'm going to sell you and I want the model to converge really quickly and only explore some of the time, then I'll probably take prospect theory for that. Or another algorithm that is not necessarily just going to converge on a group. So you need to decide kind of across the 3 levels, the person, the collective, or the society. Because if the model is at a societal level, it means that I've got a data point or data points that I'm collecting across a broad spectrum of the population that's way bigger than if I collect data on people that look like you. So that means if I set the context that anybody that, you know, has come in and they are 20 years old and the person that comes in when they're 50 years old, I want it to look different. I want the model to converge differently. Those are 2 different contexts that get set. So that means that not setting context, making the population much wider, and then all the way through to just making it for Nicola, you want the model to converge just on you, you probably will change your approach. So there are different algorithms. And the same thing with, if you take the anti-recommenders like a coverage-aware Thompson sampling, as well as the reverse of it, of being popular, it's not unpopular. It's selling and taking the items that you want to test. It's a bit like when you listen to music, all right, on a playlist. Here's a classical example. You have a playlist with 5 songs, and you listen to them for weeks, and you listen to one of the songs more than the other songs. So that becomes popular. So every time you play it, the recommender will disproportionately more recommend the one that you like than the ones you don't. Now you get to a point where you add 2 more songs. So what happens now is that because you don't have evidence of activity of that song, the explore under the classical algorithms will pick it up. But a behavioral algorithm that is not going to run, if you run like a coverage-aware Thompson or a weighted regularized matrix factorization that creates a matrix of the content, and it keeps on finding out the items that have not had evidence created for themselves, for that interaction, you want to recommend them first, to first put them on the same footing as the ones that were there before. So the behavior, that's why the design of the behavior that you expect using the algorithm that is fit is something that really needs to be considered all the time. Anyway, that was just a point. And the same thing when you take like graph theory and you use a network algorithm to deal with centralities. If you know that the centralities work quite quickly because it will converge on a page rank. That's the current algorithm that is in our network algorithm. So that will also then have a different set of behaviors around how it converges compared to others. So they each have a different approach. But I can tell you now that the tests that we've been doing on things like generic product recommenders and so on, loss aversion is an incredibly good performing behavioral algorithm.
We have a quick question in the Q&A. It's from Louvo. To sum up what we are talking about so far, are we talking about how we interact with tech in terms of algorithms and how we interact with each other through tech in a work environment? Can we have a bit of just clarity on that?
Well, this is about a product kind of view more than a generic tech scenario. So that means that if you want to interact with a person and provide the right color background, the right banner, the right message, the right nudge, the right offer at the right time to people outside the company, most of this talk I thought was about that. So it's not really about what happens inside the company. Sorry, Jessica, you can give an answer to that. I just thought it might be good to get that clarity. Yeah.
No, you answered it exactly right. It's very much about how you can use the algorithms to communicate or interact or make better recommendations or offers to the person on the other side of that screen.
Thank you. I think that clarifies the question. Are there any other questions or thoughts anyone would like to share? We do have 10 minutes, so the floor is ours. If not, I think we can call it an evening. Thank you, Jess and Eric, for that presentation.